In this video, we're going to prove the product rule for derivatives. The product rule works when you need to take the derivative of one function times another function. Whenever you have two functions being multiplied together, unless you can simplify it down in some way so that you no longer have that, you always have to use the product rule. So once again, for all the derivatives we're proving, we're going to use the limit as h approaches 0 of the difference quotient, f of x plus h minus f of x all over h. So I've already thrown that in our function u of x, v of x, one function u times the other function v, into that difference quotient and that limit. So we have the limit as h approaches 0 of u of x plus h, v of x plus h minus u of x, v of x, all divided by h. And we're going to use, for this indeterminate limit, a little trick that works for quite a few of the rules that we need to prove, is we are just going to add and subtract the same term into the numerator of this. Now, it may seem like it's kind of an arbitrary decision what I'm choosing to throw in here. I'm going to add in u of x plus h v of x. And if I add that into the numerator, I also have to subtract it because effectively that's like doing nothing. So I'm going to add u of x plus h v of x and subtract u of x plus h v of x in the numerator of this limit. Not really fundamentally changing it, but putting it in a slightly different form. And the reason I'm going to do this is because now I'm going to take the first term in my numerator and the last term in my numerator, and I'm going to group them together into one single limit. So we're going to have a limit as h approaches 0 of u of x plus h, v of x plus h, minus this fourth term, u of x plus h, v of x. And if I do that, that means I have to then separate these other two into their own limits. Don't forget this is all over h. So the other two terms will be a limit as h approaches 0 of u of x plus h, v of x, minus u of x, v of x. And that is also still all over h. So now if we look at our first limit, we can see that both of the terms in the numerator contain a u of x plus h term. So I'm going to factor u of x plus h out from this whole fraction. And as I do that, I'm going to end up with u of x plus h times v of x plus h minus v of x all over h. And when I do that, I'm going to separate that into two different limits being multiplied together. So a limit as h approaches 0 of u of x plus h times a limit as h approaches 0 of v of x plus h minus v of x all over h. And I've only put the second limit over h because this is two different things being multiplied together. I can't put an over h on the first part of it because then I'd have an h squared in the denominator, which is not what I need to have. If you then look at our other limit, we should see that there are common terms of v of x in both of those. So now we're going to do a similar thing that we did to the first limit, is we're going to factor that v of x out, and we're going to separate it into two different limits being multiplied together. So the first one will be a limit as h approaches 0 of v of x, as we factor out the v of x. And the other will be a limit as h approaches 0 of what's left, which is u of x plus h minus u of x over h. And the same applies. The h can go with either one. We're going to choose this one. And the reason why we've chosen the h to go into the denominator here for the v of x plus h minus v of x and the u of x plus h minus u of x is because if we look back up here in the top corner, these look just like a difference quotient for v of x, and then the second one for u of x. So as h goes to 0, u of x plus h just becomes u of x. And the limit as h approaches 0 of v of x plus h minus v of x all over h is just the limit as h approaches 0 of the difference quotient for v of x, which means the derivative, or v prime, of x. As h goes to 0, v of x is just v of x. And our last limit is just a limit definition of the derivative for u of x. The limit as h approaches 0 of u of x plus h minus u of x all over h. So that becomes the derivative of u, or u prime. And there we have the product rule for derivatives. The derivative of u of x, v of x, is u of x times the derivative of v plus v of x times the derivative of u.